I mean, we're using the TIs and technology to do our computations. We don't want to do these computations by hand over and over again. It's annoying. I do have one more thing I want to compute by hand later on, but not this. Okay. One prop z int. Just shuffle up the data a little bit. 163, 1734, and I'm going to go ahead and make this be green for April 2013. I like what Rory did earlier. When I asked the percentage of homes, he got a very quick estimate of the percentage by saying it out loud. About 10%. And it was close, it was 9.3. I love that. What Rory gave us was what's called a point estimate. A point estimate, which is the middle of the confidence interval. That's what statisticians call a point, a single point estimate. It's not useful by itself, but it is nice to start from, and then you can build the rest of what you need. So, you guys got an interval for me? You gonna find any success on your intervals? Decent? Good? So, tell me, what percent of for sale homes in Bend were in foreclosure in April 2013? Be brave! Work. 9.4. 100% confident? Oh, not 9.4%, you're not. You're 0% confident in 9.4%, aren't you? Why am I being a bastard and saying this? I'm such a bastard by saying this, aren't I?
We have a margin of error?
If you just give a point estimate, if you just say 9.4%, you have to be 0% confident. Because that is simply one number. And technically speaking, it's 9.4002306.8, blah, 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 blah. So if you just say 9.4% and put it right here, you have no confidence in that, because if you sampled 1,734 houses again and checked them, would you get the exact same number? Most likely not. Would you get close to that number? Good, I love that faith. Most likely, but there's a possibility you won't. There's a possibility one of those two values is an outlier. There's a possibility they're both outliers. Not a very good chance. But there is a possibility this isn't even close. But I guarantee if all you give is the point estimate, you won't be close. So that's why you slap the margin on. So the margin, you're 95% confident that it is
Between 8% and 10%.
That's what I like to hear, to 8 and 10.8%, right? 8%. Rory, go ahead, give me that question.
Can you do like 2.5% or 5% of like 1734? Now we could, like, how much unconfidence you have left?
It would if, can you hold that question?
Okay.
That's a great question. I have a nice series of graphics I think will answer it. I didn't want to jump into them right yet. And it's okay if you don't mind finishing the quiz out first. The answer is you shouldn't do that because we're mixing and matching percentages then. You're mixing and matching, and this is one of the problems with dealing with the confidence percentage and the percentage in your sample, which are not the same thing. Confidence is something you set before, Ben, you brought this up last time, right? Confidence is something you set before you do your study. I think that was you. Somebody brought that up on Tuesday. You set confidence first, then you draw your sample and do the division and get your percentage. So you can't really mix and match those things. It's kind of like you put gas in your car, you start your road trip, you can't then go futz with the gas, it's in your tank.
Yeah.
Does that make sense-ish?
Yeah. It's percentage of, based on like percentage of, yeah.
Yes, sir.
That's your confidence.
Right, percentage of what?
Yeah.
Percentage of homes, percentage confidence.
Yeah.
Apples, oranges. Good, great question though. It seems like you should be able to because it's just percentages. You just can't because of that. Thank you for that. And I actually have two answers for you. We're going to answer it quickly soon and then in more depth in 45 minutes-ish, somewhere before the end of class. So I love that question. Very, very good. Okay, so I mentioned, thank you for this interval, it's gorgeous. How does it compare to the other one? So this one here was centered at 9.4%, right? And this one here was centered at 9.3%, give or take a smidge.
It's smaller because your sample is larger.
Oh, Chris, say that again, nice and loud.
It's smaller because your sample is larger?
Did you guys catch in the fact the margin of error is smaller on this one? If you look up at that one, using Connor's trick, actually I can't do Connor's trick in my head, so I'm going to do 8 minus 10.8, it's 1.4% margin of error-ish. I can't do Connor's thing in my head, but I can. You can look at the width of the entire interval and divide it by 2, that also gives you the mark. So it's 1.8 versus 2.2. Chris just said it's smaller because your margin is smaller. Thank you, sir. Or excuse me, it's smaller because your sample is larger. Yes, 100% correct. Very, very good. How about their centers? How about their centers? How do they compare? Go ahead, be brave. Ish.
Very close.
They're very close, right? They're 0.1% off. Why did I calculate this second grain interval many years ago when I actually collected the data back in 2013, many years, last year? Why did I collect it? Because what did I read in the paper? Foreclosure rate went up, jumps. I believe the word was jumps that was being used. Foreclosure rate jumps. Well, yeah, it went from 9.3 to 9.4%. But the sample went from 9.3 to 9.4%, right? How confident am I, therefore, in saying the foreclosure rate jumped? I'm 0% confident in saying that, unless all I'm comparing is the sample from 2010 and the sample from 2013. If that's all I'm interested in comparing, number one, you're correct. Number two, get another job. Because nobody's paying you to analyze samples. They're paying you to draw a sample and apply it to the population. That's what the margin of error does. What conclusion can be made about the foreclosure rate from 2010 to 2013 based on these intervals? I'll tell you this, it's a trick question. What conclusion can be made? There is no conclusion to be made. You can't say anything. It might have gone up, it might have gone down, it might be exactly the same. Think about it this way. Think about it this way. I've got some images that with little fishies in them in a minute we're going to get into. We'll get to that in a second. Where is, with 95% confidence, where is the foreclosure rate in 2013? Where is it with 95% confidence?
Somewhere in that green box.
Say that again, Aaron.
Somewhere in that green
It's somewhere in this green rectangle, correct? It might be up here. It might be right there. Where's the foreclosure rate in 2010? Somewhere in the orange interval, right? So if indeed it was here in 2010, and this one is here in 2013, then yeah, the foreclosure rate did go up, correct? It did go up. But that's a big if it were. Do we know it was? No. Where do we know it was with 95% confidence? Somewhere in the interval. It's just as likely that it was here in 2010 and is here in 2013, which means it went down. It's also possible, and just as likely as either of those two scenarios, that it was here in 2010 and is here in 2013. In other words, it didn't change at all. See, the problem is there's too much uncertainty. We can't tell where anything is. All we know is, with 95% confidence, it's either here somewhere in 2013 and it's here somewhere in 2010. But because those intervals overlap each other, there's no decision as to where exactly they are. Hopefully that makes sense. Now, Chris, suppose we were able to sample hundreds of thousands of houses. What effect would that have on the margins of these things?
Even smaller.
It would bring them down even smaller, right? We'll deal with that as we go through. Let's do one more interval and then take 5, shall we? Let's keep this ball rolling. Because I checked it again in December of 2013, and I checked it again about 4 days ago. Let's just check the December 2013 one, and then come back after break and analyze that October 2014 one. Swing over here. Go ahead, you guys practice. You guys answer this one, then I want to get back into I want to answer Rory's question, which is fantastic.